This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 94. We talk about the Ansys Indy Autonomous Challenge Simulation Race, along with news and events from the world of Ansys. Welcome. I'm Eric Miller, one of the owners of PADT and your host for this podcast. It's the start of August, and unfortunately, the Delta mutation has turned things back a bit. Everyone's response to COVID-19, we're all reassessing it and all making adjustments as we go. So I hope everybody out there is staying safe and that you and yours are not too adversely impacted by this latest surge. We have a lot to cover today, a great interview, and a look at Ansys Inc.'s financial numbers and some news from PADT. So let's just jump right into that interview. A while back, we mentioned on the podcast that Ansys Inc. was one of the sponsors for something called the Indy Autonomous Challenge. The race is for university teams to develop AI-driven control software that they will then upload into identical, fully autonomous open-wheel racing vehicles, and they're going to be able to run those vehicles fully autonomously at the Indy Raceway, which is pretty cool. As part of that program, the teams use Ansys software to design and test their controllers, and then they use those controllers in Ansys Speos to test things out and compete with one another in different ways. The whole process culminated actually on June 30th in something called the Ansys Indy Autonomous Challenge Simulation Race. So it's basically a virtual race using Ansys software and then the control software that these students have written to race against each other. So we're lucky enough to have John Zinn, who was the sponsor from Ansys and helped the students, and student leaders from two of the teams that competed. In fact, the number 1 and number 2 team, Filippo Paravicini and Alexander Wisnowski. I'll let them pronounce their names more correctly in the interview, and I'll also let them explain more and talk about how they use the Ansys tools and what they did. It sounded pretty exciting, pretty cool opportunity for everybody involved. I'm really excited today. Thank you for joining us for a really cool discussion. Yes, we're going to talk a little bit about simulation, but even more fun is we're going to talk about two things that are really cool, which is racing and autonomous vehicles. And I'm joined today by some folks from both Ansys and some teams competing in a autonomous vehicle race that's going on that Ansys is a partial sponsor of. And I'll let them explain the details on that and all the proper names and things. But first, let's meet our guests. Alex, can you introduce yourself and let us know your background?
Yeah, hello from my side. My name is Alexander Wisnowski, and I'm a PhD student at the Technical University of Munich. My research is in autonomous vehicle control, so that's about calculating steering, throttle, and brake signals to actually move the vehicle around when it's operating autonomous. Our team has been in the autonomous racing area for 3 years already, working with a variety of companies. So that's why we decided to engage in the Indy Autonomous Challenge.
Great. How about you, Filippo?
Everyone, I am Filippo Paravicini. I'm a PhD student in automation and control engineering at Politecnico di Milano in Milan, Italy. My research is pretty much about mobile robotics and autonomous driving stuff regarding perception, so everything that regards the autonomous vehicle and the other agents, them being other people or whatever. And actually, our team to this autonomous racing.
Actually, you're dropping out a little bit, Filippo. Can you move a little bit closer to the microphone and say that again?
Should I? Okay. You guys hear me well?
A little bit better. Yeah.
Okay. Should I start from the beginning? Do you want me
No. Just the last bit there about the team.
Yeah. So the team is let's say brand new. I am part of a research group that is pretty much experienced with a lot of stuff concerning vehicle dynamics and vehicle control. But this is our, let's say, one of our first experience as an autonomous racing team. We learned about the competition pretty much by chance because one of our friends was in the States in Greenville, working for Clemson, which is one of the main partners of the competition. That's how we discovered about the competition, and here we are. And that's pretty much it.
Great. And both of you come from very important automotive cities as well. So a lot of heritage there that you're bringing to the table along with all the autonomous stuff. So that's amazing. John, why don't you introduce yourself and then explain the Indy Challenge, the Autonomous Indy Challenge to us?
Sure. My name is John Zinn, and I'm with Ansys, and I serve as the Director of Global Autonomous Solutions. So I'm working with our enterprise customers to deploy large-scale cloud-based autonomous vehicle simulation to perform system validation. And I joined Ansys about a year ago, and since then was able to get involved with the Indy Autonomous Challenge. The Indy Autonomous Challenge is modeled after the DARPA Grand Challenge autonomous vehicle races at the beginning of the 2000s, around 2004. And the Indy Autonomous Challenge is a university race team competition where the teams are competing for $1.5 million in prizes in a head-to-head high-speed autonomous race at the Indianapolis Motor Speedway. The physical race is planned for this October 23rd at Indianapolis Motor Speedway, and a top prize of $1 million will be awarded to the first place team to complete a 20-lap race in under 25 minutes. And that means that they will be driving at an average speed of over 120 miles per hour. The competition started with about 40 teams, and a lot of those teams have combined, and over the past year, the teams haven't had access to the physical race car as it's been designed and developed and as they are currently being built. So over the past year, simulation has kind of been a vehicle for the teams to work on their algorithms, their control algorithms, and to test it. And so Ansys sponsored the Indy Autonomous Challenge Simulation Race, which was held in May to gauge the performance of the teams using simulation software to compete in a head-to-head race.
Very cool. So two things going on here with Ansys. One is you know, as a sponsor and giving the teams tools to use to help design and program and test their vehicles. But it sounds like also there's a virtual race, which is what got my attention in a blog article that Ansys put out and ended up being this phone call. Can you talk a little bit more about the race itself? You know, was it the full 20 laps and how it went?
Sure. We had 17 teams that competed in the actual simulation race. Two teams collaborated on one race vehicle. So we had a total of 16 race vehicles that competed. And the teams went through various stages, kind of replicating the same types of activities that would happen at the Indianapolis 500. So we began by having the teams complete a single lap time trial, and where they were the only team racing, and then we measured that performance. That kind of seeded their position going into semifinal heats. But before we conducted the semifinal heats, we held a bunch of practice race starts where we would assemble a grid. In our simulation race, we're racing 8 vehicles at a time, 8 out of the 16. And so we're going from the time trials, which are just focused on, you know, single vehicle execution, to now looking at vehicle to vehicle interactions and making sure that the teams are able to have the right collision avoidance and obstacle avoidance algorithms in place. And so we went through a series of practice starts, and then that led up to 2 semifinal races. And then the top teams from the semifinal races went on to the final race. And we had 7 teams total competing in the final race. And instead of performing the full 20 laps, the simulation race was abbreviated to just 10 laps.
Great. And what Ansys tools were used to do the virtual race itself?
Yeah, the virtual race was performed in Ansys VR Experience Driving Simulator, powered by Scanner. So this is we had a model of the Indianapolis track, and then the vehicles are competing on that model of the track. And it really was a unique opportunity because in most autonomous vehicle simulations, you have one ego vehicle and you have other actors that are around. In this case, we had up to 8 independent controllers that we were synchronizing in one massive simulation that was running on the cloud.
Mm.
And so all 8 controllers are synced to each other. And then each controller solves the current time step and produces commands for the next time step. And then the simulation advances one time step.
That is so cool. Early on you mentioned the original DARPA challenge. I remember watching a video of that. I think it was in the desert somewhere, and
right.
the cars with these gigantic arrays on top driving off the side of the road as they were trying to figure it out. We have come so far. That's pretty cool to be able to do it virtually. So the guys that competed, Alex and Filippo, what was it like to be watching that race as it was going on, and was it pretty cool and exciting, or was it just watching numbers on the screen?
Should I go?
Please.
Yeah, it was. So we basically before the actual race, we actually did a lot of, let's say, preparation tests, if you want. So kind of races between ourselves. Actually, we did many of those with the TUM, so with Alex. The point is that, as you may imagine, the simulation may get quite complex. So while you simulate, let's say the simulation doesn't proceed exactly at the real time, is actually kind of slower. So it was kind of breathtaking because we had the rendering of the simulation that was going on in front of our eyes, but it was not exactly going at the real time. So you were watching these cars competing, and you were like maybe starting an overtake, and it would take some time to actually see if you managed to do it or not without crashing. So yeah, it was interesting to do this kind of simulation, but it was actually much better to see the final results. So.
Yeah, watch it after it's done. Yeah, very cool. I just think that's amazing, and I didn't think about it that way, but because there's a little bit more tension there because you were waiting for it to solve the next time step, yeah, that could get you on the edge of your seat for sure. How about you, Alex? What was your experience watching the final race?
Yeah, so for us, I think the situation was that we always had the target to focus on preparation for real world driving. So we haven't been going too deep into like detailed optimization for the Ansys simulation. So we've been doing a lot of preparation sessions with Polymove, which were like run on a daily basis. So what we did basically is we met every evening, launched the simulation together, and then it was simulated overnight, and then in the morning you could watch the videos together at real time. That was pretty exciting. And as we got to the race, I think both of us were quite confident that we had a good preparation. But as racing is, everything can happen, and especially in multi-vehicle situations, there's always a little bit of chance involved. So what we learned from these testing sessions with Polymove was especially that if you want to be on the safe side, you're losing in many situations a position you don't really have to give away. So we've been approaching this from a rather defensive point of view, increasing our aggressiveness in driving. So I think pretty much for both of us, it was like the question in the end, if you have been hitting the sweet spot between making a bold move and saving your position, or getting an overtake done, or if the software was getting overconfident, which could have been leading to a collision with someone, because they are also maybe on a rather aggressive line. So there has always been this remaining uncertainty, just because also we have been like testing with Polymove, but not with some of the other teams. So you don't know how they have been working on their controller. So there has been a lot of residual uncertainty, which we definitely faced during the race. So it was a great experience to see the final results.
Yeah, and as a former fan of Formula One, I can say I think it's the exact same thing with the non-autonomous racing, right? Is that question of how aggressive are you? How much do you weight? Even more so in say NASCAR, which is often more of an endurance race than a tactical race than an aggressive race. So great to see that it fold over into the fully autonomous race cars as well, which is pretty cool. Um, I want to talk a little bit about SCADE, and I think that I know that Polymove is using SCADE. I don't know if Toom is as well. Can you talk about the Ansys SCADE product and how it helped you do your control software a little bit?
So yeah, as I told you at the beginning, we are a fairly new team in terms of autonomous racing.
Mhm.
Even if we have a lot of dynamics and stuff like that and autonomous driving, we didn't have an autonomous racing navigation stack ready to be used. That means that for the Indy Autonomous Challenge, we started from scratch. We had the full choice, blank page in terms of what type of software or language, whatever we wanted to use. So at the beginning of the competition, we got produced to SCADE by the Ansys team. And since this was, product of the same computer, it looked to us like a reasonable and clever idea and smart idea to go for SCADE. I gotta say that the integration with the simulation was pretty easy. So that allowed us to be pretty quick in our development. It wasn't particularly. There were no big challenges for us to integrate our control algorithm in that kind of environment. 100% honest, I've got to say that one thing that we were lucky not to, that was not required in that type of environment, were strong perception algorithms, because the sensor side, let's say, of the competition was not exactly identical to what we were. So we didn't have the chance of testing that part, and I'm not exactly sure of how we would have managed to put everything into SCADE. But we as I told you, we are pretty much beginners, so I'm fully sure that there are many capabilities and there's a lot of potential in that software that we didn't have the chance of exploring. But yeah, so I think that in the end we got a decent result. We were satisfied. So yeah.
That's fantastic. John, so I just as he was talking, I realized I know what SCADE is. You guys know what SCADE is, but some of our listeners, maybe on the fluids or mechanical side, even the HFSS side, can you just give a brief rundown of what Ansys SCADE is and why you would use it to program the controller on an autonomous vehicle?
Yeah, Ansys SCADE is a tool that Ansys provides for embedded software development that has built-in integrity checks that allows for validation of the code that you're building so that you can validate the functionality of the code that's been developed.
So instead of just writing lines and lines of code, you kind of develop it along the way with the checks built in. And if I remember correctly, it came out of like the Airbus controls efforts to make sure that they were safer. And,
yeah, exactly. SCADE has a long legacy in aerospace, and also is applicable towards automotive, and autonomous is a great application for SCADE.
Right. It's not just a throttle by wire anymore, right? The whole vehicle is a very sophisticated control system, and safety is tantamount. So that's why SCADE. I think our customers that use it feel like it's such a great tool for them in this application. That's great. So I forgot to ask, who actually won the race?
Should I answer?
A good question for Filippo.
There we go.
We did,
Great.
but UM gave us a very hard time. Actually, they got us very scared. Alexander before was not exactly explaining the thing in the details, but the reality is that we invited them to the preparation sessions, these race prep sessions that we did on a daily basis, and they came to the first session with a very how can I put it in an elegant way?
Unexperienced driver?
No, with a very safe driver. Let's say with a very safe driver. So they were always giving up space to us. They were always getting because they really didn't want to crash into anyone, And then as the time passed, they got better and better and better. And the last week they got us. We did some sick races. They were very good with tons of with people getting the slipstream and taking blocking. Very good races. I would say 2 or 3 days. So yeah, as Alex said, the race was still totally an uncertain thing for us. We had no guarantee that we would have won and that we wouldn't have crashed into TUM or something. So yeah.
Cool. How cool. I hope you had some virtual champagne to celebrate your win on the podium. So John, you were able to watch these two teams as well as other teams. Was there something that kind of surprised you that happened during the virtual race that was kind of a wow, we didn't expect that to happen, or did it all pretty much go to plan?
Looking at the virtual race, the one takeaway that I had is that it presented itself a little bit differently than a traditional Indianapolis 500 race, in the sense that when you watch a Indianapolis 500 race, there's kind of a agreed upon path that all of the race cars are taking, and you'll watch them snake in this single line as they're performing lap by lap until they get to the right time, and then they decide to execute some passing maneuver on one of the straightaways. And the thing that was interesting about the simulation race is that you can see each individual team is working hard on developing their best path. How am I going to maneuver my vehicle around the track? And there, how I do that independent of other cars trying to find the fastest racing line. And then now you bring in other cars, and it's how do I race my predetermined best line in this dynamic environment with other race cars. So it's not as if all the race cars have decided, here is the best line, and we're all going to drop into a nice, neat column of vehicles until we're ready to pass. You do have this interesting dynamic of different teams racing on different lines, and then having to modify that line to interact with other race cars.
That is really interesting, and yeah, you definitely see that watching not just oval races but road races as well. As they all kind of follow the leader, right? And this does give them the opportunity to try and do different things. That's pretty cool. So what's next in the competition? You're actually building the real cars and going to do the fully autonomous race, right?
That's right. This summer, the teams actually get their first race cars. They're spending pretty much the whole summer in Indianapolis and are able to do some testing at the Lucas Oil Speedway. And they also have some track days set up at the Indianapolis Motor Speedway. And then that ultimately leads to the final race, which is planned for this fall.
That's fantastic. Well, I really do look forward to that. It's been kind of probably a good experience for you guys, Alex and Filippo, to use simulation and to learn a lot. Each of you, what was your biggest lesson learned as you went through up to and including this virtual race? What was the thing you'd like to pass along to maybe other college students or people in the autonomous industry?
So basically, I think there are two things we have been taking away from working in simulation. The first is one of the big challenges is that having multiple cars acting themselves is different from having multiple cars where some of them are running pre-scripted trajectories, or running on very simple models. So it is absolutely essential when we want to scale up to having AV vehicles, out in the wild, that we do simulations which involve multiple autonomous vehicles, probably also with like different software stacks, because there can be many things which can go wrong, and just like the complexity of the task is probably one of the most challenging things in the current technological development. So we think it's definitely necessary that probably like car makers have to come together and do those simulations together, not in the sense that they share code or whatever, but in the sense of co-simulation, so everybody can run his code on his own servers, machines, whatever. But it's definitely a lot to be learned from that. And the second thing, which was apparent to us, is that the capability of having real-time simulation and proper multi-threading simulation, so the capability of splitting your code on multiple CPU cores, that's something you definitely have to do to utilize the full potential of the hardware you have in those vehicles. That's a crucial thing for a simulation environment, such that you're able to transfer from the simulation to real world. So we have seen really challenges in that part, and there was a lot to be learned. So that's from my point of view are the two main learnings. People might want to add some.
Well, to be honest, I totally second what you said. So yeah, I agree completely. Kind of going on from your first point, I totally agree. So the interactions between the cars were particularly interesting and unpredictable. And I've got to say that, of course, I mean, getting different controllers is not like nice to have, is kind of mandatory. We did plenty of races running multiple instances of the same code, of our own code, and they were not, I mean, they were interesting, but not as interesting as what you get when you have 2, 3, 4 different controllers that interact, because that's a slight change in how you approach the race or the autonomous driving problem in general make a lot of a difference. And I want to add that for us, one thing that is particularly interesting and that, at least for me,
you dropped off there, Filippo. Can you say that last bit again?
Yeah. So one thing that, in my opinion, it's particularly interesting, and that could be one of the possible ways in which autonomous racing, let's say, progress in the future, is the possibility of getting autonomous driving cars and humans actually interacting in the same environment. Because, I mean, I think that for the development of autonomous driving, that's a stage that we are not going to be able to skip, so it's not like from one day to the other we are going to have 100% of autonomous vehicles on the streets, right? So that's a particularly interesting thing that I would like to see, because I mean, seeing how autonomous driving controllers interacting with each other were causing this kind of mess, this kind of super complex situation, I would be thrilled to see.
Yeah, I could see a bunch of people sitting at their automotive simulators on their computer, hooked into a to VRX driving sim, and get the human controller in the loop as well, which is far more unpredictable than the algorithms, right? Well, cool.
Yeah, totally. Actually, to be honest, I'd actually like to see also real human driver on real car. So after we try that in simulation and we see that we don't kill the driver every time, and maybe we can try on the real vehicle.
Yes,
that would be awesome.
Yeah, yep, 100%. And definitely, if you ever make it out here to Phoenix, come to our neighborhood. There's a Waymo vehicle about every 100 yards driving around our neighborhood. So it's a good way to be in the middle of it all. It's pretty cool to watch. John, do you have any parting thoughts for Ansys users in general about this whole experience? And anything you want to pass along?
I just thought I was really impressed with the work that the teams did for being such a challenging problem to solve, and not having any other tools at their disposal other than simulation. So I think, the takeaway that I had from it is that simulation's a great tool that our customers use to accelerate their time to market, and reduce development costs by bringing simulation in early. And when you look at the autonomous industry, I've been a part of it for the past 5 years. A lot of times you see this kind of prototype first path to doing development. We're going to throw some sensors on, we'll build a testing mule, we'll collect some data, we'll get some early algorithms out there, and this is just a great example of doing something in simulation, building the controllers, and having pretty much an advanced feel for how the car performs before getting the physical car. And now that the teams have their physical cars, the learning only continues, and you get more data from real sensors, working with a real compute system, electrical infrastructure and control system, and then continuing to get learning. But they have a good foundation to explore the physical car and to explore their performance.
100%. And, one of the things that really occurred to me while you guys were chatting was, one of the reasons why motorsports are such an important thing is it's pushed technology, right? Way back, through the hills near where you live, Filippo, the Grand Touring days, and really perfecting those engines and those early vehicles from names that are household names now, right? Was all driven by racing, and of course, the Indianapolis 500 was a huge proving ground for American automotive technology for a long time. It's maybe getting close to 100 years now, and it's so cool to see it pushing and as a test bed in a way to push the technology for autonomous vehicles as well, and make it so that someday it'll be in my car, hopefully sooner rather than later. So I'm really excited about it, and I really look forward to watching the final race. I've got it on my calendar, and I want to wish both of you guys, good luck and good racing.
Thank you.
Thank you very much.
Thanks for your time, guys, and we'll hopefully talk soon and learn more about how everything went afterwards.
Totally.
Perfect.
Excellent. Thanks, Eric.
Thanks all. Bye.
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 Like I said, that just super cool. I wish they had something like that when I was in school. I think we had a solar powered car, but there was somebody inside of it. You can watch the qualifying laps, the semifinals, and the 20-lap race itself on the Ansys website. If you go to www.ansys.com/experiences/IAC race. Or you can just search for Ansys Autonomous Indy Race or something like that, and you'll find it as well. But do check it out. And as I mentioned in the interview itself, racing has always been a great way to push technology, and it's great to see that this tradition continues into the autonomous and virtual worlds as we do more and more with that out there for both commercial and I guess retail driving, we would call it, when people like us are driving around, not just trucks and things. And this will help push that technology and motivate and train a group of new students to be the leaders in that area. Ansys software is used across many racing series, all sorts of things from local little racetracks to Formula One to the Formula E racing, and companies use it to give them a competitive edge when they're doing racing. And now in this new world of fully autonomous car racing, it's great to see Ansys playing a role. The teams are getting busy getting their software loaded up in the real cars right now. They're in Indianapolis itself. And the plan is to race at the Brickyard on October 23rd. And we will certainly update everyone on that race in case you missed it. we talked about Ansys SCADE and Ansys Speos during the interview, so let's make that the commercial for this episode. SCADE allows the team to write their code in a safe way where every line is created with standards and checks. Speos then takes that code, physics models for the vehicles, and simulates the LiDAR and other sensors and runs the control software in a loop with all of that. So they're able to actually test how this all works. And if you go and watch that video I talked about on the Ansys website, you can actually see the LiDAR signal that the software interprets, the control software gets. In the case for a race, not just for this race, but leading mobility players and aerospace companies around the world use these tools along with other Ansys products to give them a real-world competitive edge as transportation moves into this world of autonomy. If you're designing a product that uses sensors and autonomy, or you are writing complex controller code, even if it's not for mobility, Ansys Speos and SCADE are something you should be looking at and look at it integrating it into your product development process. In the past, you may have thought that this type of simulation was way too complex to be feasible, but these student teams have shown that nothing could be further from the truth. So reach out to PADT or whoever you work with to get your Ansys software to learn more about these fantastic tools and how they work with the rest of the Ansys suite. All right, let's take a look at the Ansys stock. The price has climbed back up and closed on Friday, August 6th. I'm recording this on the 8th on a Sunday, and the 6th was the Friday when it closed. And it closed at $374.74. So it's still short of that all-time high back in February of $413.19, but it's working its way back up. That is a market capitalization of $32.6 billion. So pretty significant value for the company as a whole. Since our last episode, Ansys released their financial results for the second quarter of 2021, and let's go over those important numbers. But first, a little bit of a note. Ansys reports both GAAP, which is generally accepted accounting principles, and non-GAAP numbers. So to be consistent, I'm just going to report the GAAP numbers. If it makes a difference, please do check out the report, and I'll talk about that when I'm done with this little bit here. So for the second quarter of 2021, they had $446.7 million in revenue. Wasn't that long ago that was a whole year. And Q2 is usually kind of a slow quarter, so that's really, really impressive. They had a $97.7 million profit on that to give them a margin of 26.1%. So that margin is down slightly from Q2 of 2020 on both the margin and the profit side. They had less revenue in 2020 in the second quarter, but they had greater profit, or about the same profit. So the margin then was 29.3% versus 26.1%. So not a big difference, but it's there. That puts the company at $809.9, let's just say $810 million year-to-date revenue. And that's up 17% from $691 million at the same point in 2020 at the end of the second quarter, halfway through the year. Profit is up year-to-date as well at $166 million versus $143 million at the same time last year, but with a slightly lower margin of 20.6%. Because many Ansys transactions are multi-year, and when customers pay is all over the place. Sometimes they pay by the month, sometimes they pay by the year, sometimes they pay every other year. One of the things they started doing is reporting something called the annual contract value. So that's what they booked. What kind of revenue over time did they book? So what's the annual value of what they sold? And that number is also up. It's up by 25% for the same quarter compared to the same quarter last year at $430.5 million. And it's $750 million for the year to date. So it's a nice big round number that looks good. The other number I like to look at, it's actually two numbers, is cash on hand as well as what the debt is. So, how much powder they have. And as of June 30th, 2021, cash is sitting at $958 million. So it's getting close to that $1 billion mark. That's up $45 million from the start of the year. And debt is $753 million. And that gives them a net nest egg of $204 million. So that's plenty of dry powder for another acquisition for a small or medium-sized company, and they got plenty of room with that kind of cash to take on more debt. So strong numbers, and they continue to show commitment to investing in people and technology. That's one of the reasons why the margins are probably down, is making that investment, and compared to their historical levels. So I think that's really good to see. If you are more interested in this and want to dig into the numbers yourself, head over to investors.ansys.com and click on the Q2 2021 results or any past quarters if you would like, or years if you'd like. There's a lot of really good information there, and you can get much more into the details. And you can also read their press release where they kind of talk about why some of the things happened the way they did. So let's move on to general Ansys news. That was, of course, their big news. The other news they reported since the last time we talked on this podcast, where they announced that they won two. One is the company won an award, and the other is some employees won the award. The employees, five Ansys employees, were named as prestigious women of color in STEM. And they were recognized for their contributions to the STEM community and to the industry as well. So that was really good to see such a large number of Ansys employees of the female persuasion and representing different groups of people and diversity within the company, and is an acknowledgement of the commitment not only of the company, but I know personally from working with them, of the employees to make a difference in STEM and to reach out to communities that are maybe underrepresented otherwise. And the second one was a corporate award. Ansys was named to Fast Company's third annual list of the 100 best workplaces for innovators. So that's kind of a cool one, right? It's not about numbers or anything like that. It's about if you're an innovator, this is a great place to work. And yeah, if you look at all the new capabilities and tools and functionality they're adding to the code, yeah, I agree with that. That's definitely a great place to work for that. All right, we also have some news for PADT. We did a press release last week. You may have seen it, but if not, I'll go through it pretty quickly. And we basically announced a leadership expansion in our sales and support department. And that impacts many of you who listen to this podcast, because that's the group that sells Ansys and provides technical support for Ansys. So over time, the number of salespeople and engineers who sell and support Ansys Stratasys 3D printers, Flownex simulation software, and more recently we've added EOS metal 3D printers and GOM scanners. That's all grown over time, and we needed to rearrange some things and provide some focus where needed. So we promoted, I'm going to talk about the three people who were promoted. The first one is Ted Harris, and he is now the Director of Simulation Support. Alan McNeil is the Director of Enterprise Solutions and Alliances, and Catherine Pesta is the new Director of Sales Operations. So many of our listeners may know Ted. He's been running our support team for 25 plus years and has been on this podcast many times, as has his staff, and he still takes a massive amount of the tech support calls himself. As part of this change, we've divided our technical support team a bit, creating a team for pre-sales, kind of application engineering, and a team for the technical support. And although engineers in each team, as well as our consulting group, do both, they're focused, they'll now have a primary focus, either pre-sales or post-sales work, so that we can schedule them a little bit better. They can concentrate and develop their skills a little bit better for each of those, but they'll also continue to do support, and that won't change too much, just their focus. Doug Otis, also a frequent guest in this podcast and the other person that takes on a lot of our tech support calls. He's now stepping up and running the application engineering team. And Ted, for now, is going to be the acting manager for the team of support engineers, as well as the department, or the overall group head as the director of support for software. So the next person I want to talk about, and if you've worked in aerospace or national lab and you're an Ansys user, you may know Alan McNeil. He worked in the strategic accounts at Ansys before joining PADT, and he is heading up a new group where we will place our salespeople who handle those enterprise accounts, those large accounts and strategic accounts, for both Ansys and Stratasys. He will also carve out time to focus on our partnership with other vendors beyond Ansys and Stratasys. So Flownex, GOM, EOS, and some other folks we are talking to, who we will talk to in the future, that would be a good fit to complement the other tools we're selling and supporting. Alan's going to be in charge of developing those relationships and managing those sales. So a little bit of focus there on enterprise and other non-Ansys, non-Stratasys sales. And a group of people we don't talk about enough on this podcast is our sales support team. And Catherine Pesta, who some of you may have interacted with or not, has been promoted to run the operations for the whole department and help the salespeople and engineers be more efficient, do more and more strategic marketing for our reselling part of our business, and keep the wheels on the bus. This is the most important thing that she does, is keep the wheels on the bus and keep them turning. In fact, this podcast and our wonderful producer, Trevor Rubinoff, report to Catherine. So this is really their production with me just yakking in between. So we're really excited about all three of them agreeing to step up and take on more responsibility, both with people and tasks. And we think that in the end, it will provide you, the customers, with better service and allow us to grow faster. Now, having said all that, we are still hiring both salespeople and application engineers across the company. Do check out padtinc.com/careers, or just go to our website and click on careers. And you can see what we're hiring for. And if you're interested in working, or you know somebody that's interested in working for us, please apply. And do note that we do have just a generic position that's posted. So if you don't see something that's a perfect fit for you, don't hesitate to apply to that generic position. We have hired people from that where we just 2 months from now or a month from now, we're like, wow, we need somebody to do A. Oh, wait, we've got a resume for that. So don't hesitate. Again, you or your people you know who are interested in working for PADT. Many of the positions are across the West. They're not all in Arizona. And we'd love to hear from you. And congrats to our three fantastic employees who have stepped up to take on these greater management positions and help make our sales and support a better thing. I'm going to skip the Ansys blog because we've gone kind of long with this other stuff. Quickly go through events. Our next webinar is on the 11th of August, which is, I think, Wednesday, and it's Discovery Updates in Ansys 2021 R2. As always, you can go to brighttalk.com or go to our events page at padtinc.com/events to figure out how to sign up for that. Also, I am going to be getting on a plane for the first time in over 18 months. I checked it out. I did the math. It has been since early May, or April, May, January, February, March, early March since I last traveled, actually. And yeah, I'm a little nervous. I'll be honest. I'm just flying to Orange County from Arizona, which is an hour-long flight. But we'll see how it goes. I bought some new masks, and I'm looking forward to it. I'm going to be going to the Design, Engineering, and Build Show. It's the new name for the combination of MD&M West, the Pacific Design Show, ATX West, Plastech West, and a couple other shows that have been put on by the same organization there in the Anaheim Convention Center for a long time. They're integrating them even more and more every year, and now it's called Design, Engineering, Build. We'll be in booth 3461, and I'll be talking about simulation in that booth, as well as some of our Ansys folks, sales folks, and anybody else that is there in California will be showing up off and on through the week. I'll be there on Tuesday and Thursday. On Wednesday, I'll be hosting the 3D printing track. That's August 11th at the conference part upstairs in the meeting rooms. And Jeff Wells will be in the booth on Wednesday. So we're focusing just on simulation this time, and we'd love to have you, if you're an Ansys user, stop by and say hi and tell us you like the podcast. Also, later in the month, we'll be going to our second show. We packed them both into the same month, the Space Symposium. That's in Colorado Springs, the 23rd to the 26th. We're going to be in multiple booths. We're going to be in an Arizona booth. We're going to be in a combined Flownex EOS booth, and we'll also be in the Stratasys booth there. So look for people in PADT shirts wandering around if you're going to that show. I'll be in the Arizona booth. Last but not least on the event calendar, if you are local, I'll be doing a virtual chat. Actually, you can do this from anywhere. I don't know why I said local, because it's virtual, with a local accelerator called Chandler Innovations. And it's a little bit of a fireside chat with a friend of mine, Tom. And we're going to be talking about defining and understanding your market. And although this is aimed at startups, it's an important topic for anyone involved in product development. In fact, if it's an existing product or an existing company, it's just as important to understand your market. And if you're an Ansys engineer, as you probably are if you listen to this podcast, it's still important, right? It all goes back to what are you trying to figure out with simulation? And it all boils down to, understanding your market. Will in the simulation world, will it do what the market wants, right? From a virtual standpoint, we can test that. So again, anybody that's interested in that topic, please do check it out on our events page. You can register there, and it's a free event at 11 o'clock, I think, sometime in 2 weeks. So do check that out. That's it. I want to thank everybody for listening. Don't forget to subscribe to www.padt.com, padtinc.com/opt-in, which is our newsletter, which has all sorts of news and events and links. Do spread the word about the podcast. Do subscribe to the podcast if you're using a podcasting tool. And we'd love to have more people listening in. And as always, do not hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 94. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.